Hello everyone, welcome to the Spintangle. Today I am here with a very interesting problem. Okay, this problem is from this problem covered topics that are binomial distribution. Okay, binomial distributions, and you can learn from this what is mean by the number of ways or number of microstates. Okay, number of internal arrangements, and also you can learn from this thing that how to find entropy. Okay, entropy from this formula that S is equals to K ln omega. So these are the three topics that will be covered by solving this question. Okay, so let's move on to the question. First, read the question carefully. That consider a large number of n localized particles. Okay, there are n localized particles. Say there are n localized particles. Okay, there. Okay. In an external magnetic field H. Okay, these particles are in external magnetic field H. Okay, each particle has spin half. Okay, each particle has spin half. Spin half. That means what will be the value when we apply after applying external magnetic field? What will happen? External magnetic field, there will be splitting due to spin. Okay, therefore some particle will behave as that they are having say up spin. Okay, say up spin, and some particles will show that they are down spin. That means what are the down spin, what are the up spin? As the spin is given to you, that is half. That means the up spin will be what? The up spin will be of say plus half, and the down spin will be what? Say I am taking it minus half. You can take it minus half and plus half also. These are the dummy indices. Okay, so you can take anything. So what will happen here? You have n particles, n localized particles, and from n particles, some of the particles will be in the up state and some of the particle will be in the down state. That means these particles have spin positive, okay, plus half, spin plus half, and these particles have spin minus half. Remember one thing, that if you do not apply external magnetic field to these particles, they will not show that they have been splitted up. Okay, they have been splitted up. To show this kind of splitting, to this kind of spin splitting, there has to be applied and by an external magnetic field. So after applying magnetic field, there will be spin splitting. Okay, before applying external magnetic field, you cannot certainly say that what particle will be plus half and what particle will show minus half. Okay, this is the thing. So now the question, find the number of accessible to the system, number of states accessible to the system as a function of ms. Okay, ms value is what? Here I am giving ms values. What are the ms values? Yeah, the ms values is say ms value is I will be giving. Say ms is what? Ms is, you have n up particle having spin plus half, and you have n down particle, n number, these are the number of particles, n down particles having spin minus half. Okay, this is the total spin. Okay, this is the total spin. You can say like this for the system. Therefore what does it become? Say half n up minus half n down. This is ms. Okay, I am taking the half on the very outside of the bracket. Say n up, this is n up minus n down. So ms is this. Remember this thing. Okay, now I am going to the fact. Z component, find the number of states accessible to the system as a function of ms. Okay, number of states, you have to find the number of states, say number of microstates. Okay, this is the number of microstates, number of ways. You can say like this, number of ways and number of microstates are the same. The z component of the total spin of the system is what? Ms. Okay, determine the value of ms for which the number of states is maximum. There are two questions. The first question stands for you have to find the number of states, and the second question stands for that you have to determine the ms value for which the number of states is maximum. Okay, let's start with this thing. So we have the ms is equals to what? Just calculated. The ms is equals to half. These are the number of particles having spin up. Say this is spin up, and these are the number of particles having spin down. Okay, and we can also we can say that you have n localized particle. Among them there are n up particle and n down particle. So we can write this, the sum of these two things gives this n. Therefore we can write this as, we can decompose this n, total n, into this up n and down n. Okay, so these are the two equations. You have to solve this thing. So before going to solve, I am writing this thing as, multiply this 2 with this ms. Okay, this means 2 into ms equals to what? N up minus n down, and there will be from this I am writing this thing directly. Okay, this n equals to what? N up plus n down. So adding them, first add then subtract. Okay, first adding them, what will happen? Adding them, this term will cancel out with each other. Therefore in the right hand side you can write this as 2n up equals to 2ms plus n. This means n up will be what? Divide this thing by 2. Okay, there this will give n up. That means this will become ms plus n upon 2. This is the value of n up. Keep it on your hand. And very similarly you can find the n down value by subtracting each other. Okay, subtract. By subtracting you can check this thing, that this term goes with this term and they will survive. Okay, they will survive. Therefore it becomes, I am writing this thing, 2ms minus n equals to minus 2n down. From this you can easily write this thing, that n down is equals to, divide this thing by 2 and flip the negative sign. Okay, that means n by 2 minus ms. I think I am correct. Check this thing on your copy. Okay, so these are the two values of, this is the value of n up and this is the value of n down. You can easily check this thing, that this is a binomial distribution type problem. Why this is binomial? Because you have n particles, n localized particles. Among them you have n up particles, you have particles, up spin particles, number of these. Okay, and you have down spin particles, number this number. So these are the binomial. Binomial means these are the two, either this. Okay, these are the binomial. Binomial means two. Okay, binomial. This one norm, this second norm. Okay, these are the binomial. So in case of binomial distribution, what we can find the number of ways? We can write the number of ways as, number of ways. We can write this thing as, say, omega equals to n c n up. You can write this thing, and also this will be similar to n c n down. Take any one of them. Say I am taking this thing. This will become n factorial upon n up factorial times n minus n up factorial. This means you can easily see this thing. This is what? This is the total number minus the n up. This means this becomes n down. Okay, you can write this thing. So I can write this thing here, n factorial, n up factorial times n down factorial. This is the number of ways, okay, in which you can arrange the microstates. Okay, these are the internal arrangement of the microstates. These are the called states or microstates, or the number of ways. any one of them. You can call any one of them. This is the first question. I think this is the first part of our question, that calculate the number of states. Okay, number of states is what? That the internal arrangement, possible internal arrangements of the system, that number of microstates. In the lecture of microstates, macrostate, I have given an idea of why microstates are called the internal arrangement. Okay, so from this MS Z component of the total. Okay, now this is the first, find the number of states. Okay, number of states is down, and I am moving on to the second, determine the value of MS for which the number of states is maximum. Okay, number of states is maximum. When the number of states will be maximum? For omega to be maximum or extremum. Okay, I'm writing this thing as extremum. Okay, there has to contain, has to be satisfied a situation that, say, this is the differentiation of this thing. I can differentiate omega, but it does differentiate omega directly. It is a complicated process, so I have converted this as a function of omega. This becomes, and I am differentiating this ln omega, because this ln omega is easy to differentiate. So here it becomes del ln omega times, say, del n up equals to 0. This is from the concept of extrema and concept of minima and maximum, that is in Bengali medium it is called chorom and obomman. Okay, so you can easily check this thing. So differentiate this thing. Okay, say before differentiating I am writing this thing as, say, del n up. You can take n down also. Okay, so ln omega is what? N ln n minus n up ln n up. Okay, up to this thing is okay. Here is n down term. Okay, convert this n down term in terms of I can write this thing as n minus n up ln n minus n up. Okay, I can write this thing as this. This will become 0. Therefore the first term is constant, this is 0, minus the second term is what? The second term is I think the second term is n factorial. Okay, this is okay. 1 by n factorial. 1 by n factorial, and in the second term it will become ln n factorial, and here it is becomes minus, differentiate this thing. It is easy to differentiate, I think so. Say it is n minus n factorial, and here will be a there is a minus sign, I think so, and n minus n factorial. Differentiate this thing, easy to differentiate. I think 1 by n minus n up. So this is up, and the second differentiation will be on minus this thing. This will become plus, I think so, plus ln n minus n factorial. Up to this thing, this is okay. There will be a positive sign. Okay, these two times will be positive, and this is 0. You can check this thing, that this is minus 1 minus ln up plus ln n minus n up equals to 0. You can check this thing. This is what? This is 1 plus 1, and this is what? This is minus 1. These two terms goes cancel with each other. Okay, so that becomes, so I'm not writing this minus 1. This is minus ln n, and this thing is 0. So from this, what we can write this thing as minus ln n factorial is equals to ln n minus n factorial. So from this thing, what we can take, say, n factorial is equals to n minus, not a, I'm calling this thing n factorial. This is not n factorial, this is n up. This is 2n up equals to n. This means what? This means n up equals to what? Capital N upon 2. This is the total number of total number divided by 2, this is the half of the particles. Therefore n down will be the same, because total give n up and n down, by addition they will give total n. Okay, so this is the condition for, I think this is the condition, this is the necessary condition. Just wait, the question was what? Determine the value of ms for which the number of state is maximum. Okay, value of ms. So what is the value of ms here? I'm moving, calling from this thing. Say ms is what? Half into n up minus half into n down. So value of ms equals to half into n up minus n down. What is this? Half into n up is what? N by 2. N down is what? N by 2. This will become 0. The ms value has to be 0 for becoming the number of states maximum. Okay, this is the question. You can check this thing from anywhere. Okay, you can check this thing by your own. Change the value, take spin 1 particles, take spin 3 by 2 particle. Okay, anything you can do this thing by your own. This is a, so what we have learned from this, by how to use binomial distribution, and how to calculate the number of ways, and and the very last term, what we have to do, that the entropy will be what? Entropy of the system will be what? Entropy of the system. I think you have calculated this thing, this ln omega, I think you have calculated. And to find the entropy, what you have to do here? You have to do, say entropy is what? I am doing this thing here. Entropy is equals to k ln omega. Just multiply a k on the very front of the ln omega. Okay, that will become k times the ln omega, the value of this thing, k times this thing. Okay, so this is the entropy. So thank you for being with us, and we'll be discussing few more problems on the next time. Okay, so see you. Thank you.